Hi students, let's look at this question here, which is on partial fraction, and then after which the application of differentiation. I think this is pretty okay. So express this in partial fraction. I think the first part shouldn't be an issue. First thing is to make sure that the degree above is lower than the one below. The below is degree 4, so that's degree is 4. The reason why it's degree 4, because if you multiply this is power 4, this degree here is 3, so it's fine. You don't need to do a long division. If you need, it will be very terrible. So anyway, just write this down: x cubed plus x squared plus 5x. So as you decompose it, just remember that okay, this x squared minus 1, he has two roots, right? X minus 1, x plus 1. Remember that. This over here is actually x squared minus 1 squared, which is a difference in square a minus b, a plus b. So just split it up. So as you do your partial fraction, just remember it will always be a degree, 1 degree lower for the numerator. Okay, so for example, this case is a degree of 2, so it will be a linear, which is ax plus b. Then whereas for x plus x minus 1, it will just be a c, and this will be a d. Okay, so if you do so I'm gonna just write this up: x plus 1 plus c, x plus 1 x squared plus 3, and last one d plus d x squared plus 3 x minus 1. So this case will be x squared plus 3 x minus 1 x plus 4. So it is pretty okay. Once we've done this, we know that 7x cubed plus x squared plus 5x plus 3. Then we have ax plus b, x minus 1 x plus 1. Then c, which is x plus 1 x squared plus 3 plus d, which is x squared plus 3 x minus 1. Okay, so this is 1, this is it. So once we done that, we could start solving it. So I think just let x be 1 first, because I let it be 1, this will be 0, x is 1, this is 0, then this is 0 as well. So x is 1, we have 7 1 cubed plus 1 squared plus 5 times 1 plus 3. That will be 0 here. Then this will be c 2, then this is 1 squared plus 3. Maybe I just put 1 plus 1. 1 plus 1, and this is 1 squared plus 3. Then the other one, d, is 0, so just be 0 as well. So this case here, what you get is 16 equals to the 8c. So c will just be 2. Okay, great. So c is 2. Then after which I let x equals to minus 1. Cause this will be 0. So c minus 1, 3 plus minus 1 square plus 5 minus 1 plus 3. Minus 1, this will be 0, this will be 0. So I'm solving for d minus 1 square. Remember, bracket is 3 plus 3 minus 1 minus 1. Then what we do is just find this. So it's negative 7 plus 1, negative 6. Negative 6, negative 11, negative 8. After which d will be 4 minus 8d. So d is actually goes to 1. Alright, great. So we got d and c. Okay, now then the rest will be quite okay. I think the one which we need to solve is a. So if you want to solve a, just let x be 0. That will be the easiest. Okay, just solve for b. So a and b. So we left with 0. So b is equals to minus 1 1 plus c, which is actually 2. Then 0 as well. 1 0 is 3 plus d. 1 0 is 3, and this is minus 1. Just key in calculator. It worked out to be 3 equals to minus b plus 3, which is b is actually equals to 0. Okay, so b is 0. Okay, then x is equals to, we use 1 minus 2 minus 1 0, so we can use like say 2. So using 2 will be 2 cubed plus 2 squared plus 5 times 2 plus 3 will be 2a plus 0 2 minus 1, 2 plus 1, plus c, which is actually 2. Then after which x, which is 2. So many things, right? 2 square plus 3. D will be 1. So 2 square plus 3, 2 minus 1. Great. Then we're just gonna change this. This will be 73 equals to 6a 42 plus 7. So 73 minus 42 minus 7, that will be 34. A equals to 4. Okay. So the partial fraction that we get is actually answer is just 4x over x squared plus 3. Because it just only b is 0, a is 4, right? Then c is actually 2, so plus 2 over x minus 1. Then d would just be 1. Okay, so that's the first part. I think that's pretty okay. Second part is the interesting one, which is to show the derivative is always negative. This means show that this is always negative. Okay, when you say that is always less than 0, meaning that you want to show that the derivative is always negative. So we just differentiate it first. So for b, part 2, what we're going to do is just differentiate it first. So I'm going to differentiate thing dx 7x cubed plus x squared plus 5x plus 3 over x squared plus 3x squared minus 1. Just substitute what we have already the previous part, which is actually this is d dx 4x over x squared plus 3 plus 2 over x minus 1 plus 1 over x plus 1. Okay, so differentiating this, I think should be okay. We can use quotient rule for the first one. So okay, maybe I should just write this down. I'll just split it up. Then the other one would be d dx. Okay, then this will be x plus 1 minus 1. Okay, so this I'm gonna use quotient rule. Of course, I think that will be it will be better. So then it will be just v square v du dx, which is 4, minus of u dv dx, which is 2x. Okay, so that's pretty okay. Then at rest we have got 2 minus half. So it's just a plus. Just bracket this up. This multiplied down is 2x minus half minus 2. It's pretty okay. Minus x plus 1 minus 2. Okay, that's about it. So once we've done this, then we're just gonna expand the rest. So this will be 4x squared plus 12 minus 8x squared. Then that would be 4. Then this will be minus 2 over x minus 1 square minus 1 over x plus 1 square. Okay, great. Then what we left here is I'm going to just a lot of things to write. So I'll just slowly write it down. There's x square plus 3 square. So this is a derivative that I get. Let me just yeah. So this just factorize the negative 4 out. That will be I will just put a negative 4 out. So the negative, I put it outside. This is x squared minus 3. Okay, great. Now I need to show that this is always negative whenever x is less than negative root 3, right? So we need to show that. So how do we do it? I think there are a few ways. Okay, so first of all, I think this 2 is quite easy to understand. Eyeball this. This is always positive because no matter how, okay, I've asked you a value, give me a value of x which to make this negative, you can't, because these two expression always positive. Okay, when you square a x value is always positive, so it's non-issue. So essentially, since given that x minus 1 is bigger than 0, then x square, then x plus 2 square is also bigger than 0. So if you were to multiply, is you invert this one, x minus 1 square, this will also still be positive. So this is okay, positive. Then when you because there's a negative there, so you multiply by negative 2 for this case. This is minus 2 over x minus 1 square. Then when you multiply negative, you just remember to flip this, right? This is important. Then you multiply this with negative 1. Is it? Oh, this is 1 square plus 1. Okay, so then this will be this will be negative x plus 1 square less than 0. Okay, so you see this carefully. This is always positive. So no matter what, if it's always positive, you multiply a negative value here, negative 2 and negative 1, you'll be negative. So it's sure it's always negative. So you take this and add up with this, will be negative. Now we need to tackle is this guy here. Look at this. This is also always positive. The one below is also always positive. Okay, so we know that x square, that's why the complete the quotient rule is important. So this is always positive. This has to be the most positive among them, because this x square is already positive. This positive number you square again is of course always positive, right? Not an issue. So what you need to eyeball is the one on top here. This one will come from this over here, which is actually x bigger than the start of the x less than negative root 3. Okay, so in other words, if I were to square both sides, now when you square both sides, you have to be slightly careful. Maybe this is x squared minus 3, right? So I'm going to square both sides, x squared. Okay, let me think how would I okay, I think I will square both sides. Now when you square both sides, you have to be careful. When you square both sides, what happens is this would be the other side of the equation. All right, so that would be it. Or maybe what we could do is, okay, I'll just do this instead. So x, because the inequality there, it may be confusing, especially for O-level students. So so x plus root 3 is less than 0, right? So in order to get minus 3, we know that this is root 3 square, not an issue. So we know that x minus root 3, let me see first, minus root 3. This is the tough way. So this is not an issue. From here to here is okay. So I'll write down the other one. I'll use another method here. So x, because I just need to show that it's always negative. So this is less than root 3. So I minus root 3 on both ends. Minus root 3. This will be x minus root 3 less than minus 2 root 3. Okay. So do you see that? So if I were to take the first inequality and the second inequality and multiply them together, because these both are definitely negative, right? This is a negative value. This is a negative value. Always negative. This is also always negative. So when I take negative value, multiply a negative value, what happens is this case over here will be positive. Okay, it'll be positive because this is negative and negative. Less than 0 means negative. Any negative value. So this will be positive. Definitely be a positive value here. So this x squared minus 3 is bigger than 0. Okay, this is the crux of it. So now what we can do is actually taking 3 and 4. We just taking 3 and 4. Then now, because this is x squared times minus 4, so maybe I don't put the minus 4. I just multiply negative 4 here. This is minus 4x squared. Minus 3 is less than 0. Okay, great. So now I take 3 and 4. What I'm going to do is actually take 4 divided by 3. Okay. So just take note, the 4 is negative 4x squared minus 3 divided by x squared plus 3 squared. Because the top is actually negative, okay, maybe I do one step at a time, because if not, it'll be very confusing for you. So if I will just multiply by positive 4, that'll be easier, right? So if this is positive, so without the negative first, then this will just be positive because it's always positive. So essentially, you just need to show that this is positive, everything else is positive except for this negative outside. Okay, so then that's about it. So hence, if you multiply by -1, you know that this is 4x squared minus 3, and this is x squared plus 3 squared is less than 0. Okay, then you just sum all of it up. You sum all of it up, so meaning to say 3, 4, 5, so it's 5, 6, and 7. So 5 plus 6 plus 7. You add all of them up, will be, what did I do? -2. So x squared minus 3. -2 over. Okay, great. What else I need to do? Okay, that's about it. Less than 0. So shown. So this is it. This is my derivative of. Okay, so that's it. Shown. Yep. That's how I do this question here proficiently. If any questions, comments, please do let me know. I know it's a bit lengthy, but I'm just trying to explain as detailed as I could. Okay, so the general form is just know that this is always positive. Multiply by this negative, this will be negative. This is always positive. Multiply by this negative. The for the top is because this obviously is always positive, but the problem is this top here, given by the range here. This is given. Okay, then it will also be always positive here. Then after which you will get the whole expression like that. Okay, so that's how you do this question here proficiently. If you have any questions at all, please let us know, and I'll see you in the next question.